All right, guys, let's start off here on number 1. So for this one, I would always kind of try to isolate y here to just graph it a little bit easier. So I'm going to subtract my 2 over there. So x squared minus 2 is a parabola starting at negative, with a vertex at negative 2, which I can see that all of these graphs are. So it looks like I just need to kind of look at shading, and I need to look at the dashed or solid line. So I know that when we have a greater than or less than, that's always a dashed line. That's kind of the first decision I make versus the or equals to having the solid line. And so right off the bat, then I can cross off these two answers down here as they have solid lines. So then kind of the only decision I need to make is it above or below? So that's really based on the direction. And so these two, whether you have a line underneath or not, whether it's equal to or not, the less than is below, whereas the greater than is above. And so since this one is less than, that's going to be below, so I would do option A there. All right, next up here, they have actually a graph, and we're trying to write the system. So it looks like the first thing I see is this vertical line right here. Now, I know a vertical line is always x with a number. So in this case, it looks like that number is 15 for me. So I'm going to say 15 there. You can see they're counting by fives, and so that's got to be 15. And so the next thing we need to decide is kind of which side of the line is that on. So you can see it's to the left of that. So for x's, that's going to be less than 15. But actually, I see another line over here, and that one is also x with a number. That looks like x and 0, so x is going to be greater than 0. And so what I would say is to combine those, we can say 0 is less than x is less than 15. It's kind of saying that x is between 0 and 15. So that's what's going to go in here. Is 0 is less than x is less than 15. Okay, so the next up we'll worry about the sloped lines. So the smaller slope first. So to me that's obvious that'll be the negative slope here. And so let's see, I know that the y-intercept is 20, is a positive 20, and then it looks like it goes down 20. It goes down 20 over 20. I can definitely see that, which is really negative 1. And so I'm going to say that's just negative x or negative 1x. And then you can see it's underneath that line, so that's going to be a less than for me, so that'll go there. And then I'll let you guys try the larger slope, same idea there. Oh, and this one was a dashed line, so it's not going to have a line underneath for the green one that I pointed out. All right, next one here, they're asking us to write another system. So for this one, let's see, the linear one looks a little easier to me, and so I'm going to write that one first. And so it looks like we have a y-intercept of 8. And then the slope, let's see, it looks like it goes down to 4, 0, so that's going to be down 8 and over 4, which we just reduce to negative 2, so I'll say negative 2x plus 8. And it looks like y is greater than that because you can see from that line it's going up. Or if you want to kind of have it more descriptive here, it'll be going up like that. And so that'll be my first line, and then we're going to separate this with a comma. And so my other line is, or it's not a line actually, it's a circle. So for this one, when it's a circle and it's the center at 0, that's always going to be x squared plus y squared. And then the number here is going to be r squared, so I need to find the radius. It looks like the radius is 6, and so I'm going to make that a 36. And then it looks like it's shaded inside the circle, so that's going to be a less than here. So I'm going to say x squared plus y squared is less than 36 for my other one. And if you want to test a point here, like 5, 0, you can always do that. And so I get 5 squared plus 0 squared is less than 36. That does check out. And just to make sure it also checks out on my green equation, it would be that 0 is greater than negative 2 times 5 plus 8. And so that is 0 is greater than negative 2, which is certainly checks out as well. Write another. All right, next up here, it says they sell 2 televisions, and they want to sell twice as much, at least twice as much of brand A as brand B. So for that first sentence here, at least twice as much of brand A than as of brand B. And so for that one, what I'm going to say is I'm going to put A and B on opposite sides. And they want twice as much as brand A, so that means I need to multiply brand A by 2 to get to brand B. And then it's going to be greater than or equal to because we want at least twice as much. So A should be twice as much as B or bigger, so that's why I'm opening it up that way. All right, next up it says also necessary to have at least 13 sets of brand B. So that's pretty simple there. It's just going to be B is greater than or equal to 13. And then it says there's room for no more than 180 total sets on the floor. So that sounds like the sum, this one right here, sounds like the sum of both A and B has to be less than or equal to 180 because they can't hold any more than that. And you know what? There's actually one more inequality here. I don't really agree with this one, but it actually does make sense if you think about it. So the last one is that because of kind of the combined logic of these two, we can use like substitution here to say that, well, if B has to be greater than or equal to 13, that must mean that A is greater than or equal to 26, since A must be at least twice as much as B. So you can see that they all kind of do have that vertical line at 26, so that would be my logic there. All right, next up here we got a histogram, and so it says to approximate if it's symmetric, skewed left or skewed right. So I'm going to say it's approximately symmetric. It's not perfectly symmetric, but you can see that most of the data is concentrated towards the middle. And then we're going to determine the approximate location of the median. So on these kind of approximately symmetric ones, the mean is, I'm going to actually skip to this. The last part is about the same as the median. And so I'm going to say the approximate location is right in the middle there. So I'm going to say it's about 300. All right, next up here, I always kind of draw a little mountain on these ones, and whichever way you would want to ski down, that's the kind of trick. So this one I would want to ski down the left, so it's skewed left. And so whenever it's skewed left, it means that the mean is to the left of the median. That's actually what the skew means, is it pulls the mean in that way. And then the approximate location of the median, you know what I would do on this one? I would actually see how much data I have here. And so I'm going to add up the frequencies of each bar. So you can see that one's 1, that one's 1, that one's 1, that one's 2. So I'm just going to do 1 plus 1 plus 1 plus 2 plus 1. And then this next one is 4, and then 3. And then what is that next one? All right, so that's 7, and then 10. So 7, and then 10. And the next one will be 9, and then 12, and then 15, and then 13. All right, so I'm going to add all that up to see what's our total population here. So give me a sec to do that. 5 plus 5 plus 10 plus 10 plus 21 plus 28. Okay, so that's a total of 79. And so that means about the 40th person is going to be our median. And so kind of if I just count how many would be 40, so this is 3, that's 5, and then that's 10, and then this would be 20, this would be 10 more, so that makes 20, and then obviously this would make 30, and the 40th person would be about right there, because this would be 30, this would add up to all 39 with all the previous ones. So in that bar of 12, which you can see is right here, and so that looks like it's about 280. All right, next up here, they say an organizer has some data here for annual income, and find the average and the mean. So for the average, you can just add them all up and divide by 7. I'll let you guys do that. For me, the answer came out to 57571. And then for the median, I would have to put them in order here, so I'm going to do that. I'll just do it in thousands, so I'll go 46, 50, and then 57, 58, 58, and then 63, and then 71. And so if I kind of count in here, Looks like we only have one median, so that is 58,000. And so it says how many participants have an income above the average, so above this 57 number for me. And so it's easy to see that these four have a income above that average. And then a new person joins the seminar that makes 600,000. So it's a pretty big outlier here. So you can kind of imagine now that we have another one over here that's 600. So now our median, if we kind of did that again, I'll do it in green here, is actually the average of these two numbers. And so the average of 58 and 58 is obviously 58,000. So that's my median. And then for my average, I'd have to kind of recalculate this, add them all up and divide by 8. And you can see that that jumped all the way to 125,375. So you can see here, I'm going to actually answer the last question. The effect of the outliers on the median and the mean is that the outliers affect the mean a lot more than the median. In this case, they didn't affect the median at all. In some cases, they will affect it a little bit, but you can see it has a huge effect on the mean. And so that tells me that the median is a better indicator of the central tendency because it's not being affected that much by the outlier. All right, next up here, they have a stem and leaf plot. You may not, or a stem plot, and sometimes they call it a stem and leaf plot. You may not know what that is, but they kind of give a good description right here that 2 on this side and 1 on that side means 21. So to see how many players scored 16 points, that is really all 3 of those people right there. And then so how many players scored more than 10 points would be all of the people down here. And so that is going to be 6 for me. The total number of players on the team is those 6 plus the 7, it looks like for me, that scored less than 10 points. So you're really just adding everything up there. And so that one is going to be 13. The total number of points scored, we would just add up all the points. And so for me, that would just be like 1 plus 2 plus 2 for that one. And then this one would be 16 plus 16, etc., plus 24 plus 30. So I have to add all of those up. So it's going to be different for you, but that's how you do it. And then once you have the total number of points scored, you can actually divide, for this one, you can divide your answer to part D over your answer to part C, since that's really what average is. It's the sum divided by the number of numbers. The median, I would just count it out here. So I would just go cross off as I go along and kind of do this in order here, kind of to meet in the middle. And so for me, that's going to be this one is 9. And then the mode is the most occurring. So that was that I had 3 16s occurring there. Our next one here is asking us to solve this. So we'll go ahead and go for it here. So we'll multiply this one by -2. So we have -2x minus 2y equals 1. And then we have 2x plus 2y. Oh, wait, that should be -2 here. I forgot to multiply that. So that equals 2. So this will give us 0 equals 0, which means we have infinitely many solutions. And so if I let x equal t, which they tell me to do here, then y would equal, and I'm going to go ahead and just set this up. So t plus y equals 1, plugging in the t for x. So y equals -t plus 1. So I'll put that there. And so this allows me, so it says this gives me the infinite number of solutions. And then so now they ask me to list some of them. So if x is 3, that means that y is -3 plus 1, which would be -2. So for this last step, you're kind of just getting some of the points here. It's certainly not all of the infinite number of points, but it's some of them. Just based on whatever x they ask you to plug into your formula, go ahead and do it. All right, next up, number 10. We've got a triple system here. So I'm going to go ahead and multiply this one by -1. So I'll write that -x minus y plus z equals 0. And then just keep that second equation the same. So now I have not 2y, just 1y minus 2z equals -2. And now I'll do this top equation by -2. And then I'll add it together with the bottom equation, since I need to incorporate that one. So we get y minus 2z equals -2. Now I can already see that this is going to be infinitely many solutions. because they are literally now the same equation. So I'm just going to go ahead and solve them here. So they want me to solve this in terms of z equaling t. So I'm going to plug in a z for t, and I'm going to start on one of these two equations, and I'm going to isolate y with t plugged in for z. So that would mean that y equals 2t minus 2. And so now I'm going to find x on one of the original equations. I'll go ahead and just use the first one here. And I'm going to leave x as a variable, but plug in 2t minus 2 for y, and then t for z. And now I'm going to solve for x, which just means isolate x. So I'll combine like terms first, and then I'll subtract the t over and add the 2 over. So it's going to be negative t plus 2. All right, next up here, we got Cindy wants to invest $50,000. And it looks like we have 3 accounts here, so I'll just do x plus y plus z, and that'll equal the total of 50,000. And the next one, we got an annual return of that, so that's my percentage one here. So 0.03x plus 0.055y plus 0.06z equals 2075. And then my last one here, I should have a comparison one. Yes, twice as much in the lowest yielding as in the highest yielding. So that means that x equals 2z because we have twice as much in the x account. All right, so I'm going to start off with some substitution here. So I'll just swap out my x's and put in 2z's. And so now I have 2z plus z, so that's going to give me y plus 3z equals 50,000. I actually forgot a 0 here. And then this one would turn into 0.06z if I multiplied 2 times 0.3. So that one's going to become, when I combine like terms, 0.055y plus 0.12z equals 2075. So now I would use elimination here, so I'm going to multiply this one by negative 0.055. So that'll be negative 0.055y, and then I'll need my calculator for this. 3 times 0.055, and that'll give me minus 0.165z, and then 50,000 times 0.055 is going to give me negative 2750. So now I'll add these together. My y's cancel. I get negative 0.04. Oh, no, it's not. Or is it? Let me use my calculator just in case. Yeah, it is negative 0.045z equals 2075, negative 675. So now we'll divide that by negative 0.045, and that 675 divided by 0.045, and that gives me z is 15,000. Then I know I can plug that in here, so x is double that, so that'll be 30,000. And then I know that I invested 50,000 total, so that means that y must be the leftover, which is 5,000. All right, next up here, they want me to write the sum in sigma notation. Now they're wanting me to start at 1, which means I have to make this one a1. So I'm going to try to find the pattern here. 23 minus 9 would be 14, so it looks like this is a plus 14 pattern. And so I can write the equation then as a sub n equals 14n. I already know that. And then my a sub 0 would be kind of hypothetically what number would be in front of 9. So I'm going to do 9 minus 14, and that looks like negative 5. So there's my formula. The next thing I need to figure out is which term is this one over here, the 20869. So I'm going to plug that into my formula out front and see what I need to be plugging in to get that. So I'm going to add 5, so 20874 equals 14n. And we'll divide by 14. 20874 divided by 14 gives me 1491. So Columbus was about to sail the ocean blue there. And then we have to actually find this sum. And so that number goes up top there. But now to find the sum, I have kind of, I think, all the information I need. For the arithmetic formula, I need n over 2, so that's 1491 over 2. And then that's my n, and then I have the first term plus the last term inside of here. So you just calculate that, and you get your sum. All right, next up here, we got some conditional probability. And so it says the probability that a ball is red given that is number 6. So it looks like both of these have a number 6 there. So I only have 2 number 6s. And out of those 2, one of them is red. Next up here, the ball is green given that it is number 7. Looks like we only have 1 number 7 in this one. This one only goes 1 to 6. And so the probability that it's green is actually that 1 out of 1. It's 100%. The ball is red given that it is an even number. Okay, so this one's a little tougher here. So all my even numbers, I have 3 even in there, and I actually also have 3 even in here. So that's a total of 6 even. And out of those 6, 3 of them are red, so that's 3 out of 6. And then the ball has an even number given that it's red. Now, I'm going to do this again here. So how many red ones do I have? I actually have 6 red. And out of those 6, I do have 3 even. So it kind of is a coincidence in this case that those last 2 matched up. All right, here we are talking about, talking about conditional probability again. And it says we got 5 of the red balls and 8 of the green balls. And it says, let's say we find 2 balls are drawn at random. And then it says find the ball, probability that the second ball is red given that the first is red. Now, the first is red actually doesn't matter in this case, but we're assuming that we got that. If you wanted to calculate the first one, then the first one would actually be, what would that be? 5 red and 8, because that would be 5 out of 13. And then the second one, if I did get that red the first time, would drop to 4 out of 12. So they're actually only asking about the second one here. So I'm going to say that's 4 out of 12 or 1 out of 3. It did not say what's the probability of this getting a red on the first and the second. Otherwise, I would multiply those. In this case, it's just asking me about that second one. All right, question B here is kind of similar, but on this one, we're saying the first one was a green. So the first ball being green was a probability of 8 over 13. And then the second one is red, given that we got a green. So that means there's only 12 marbles in there, but there's 5 red ones because I got a green the first time. So once again, this is just asking me about that second one. All right, and then this next one, the second ball is even numbered, given that the first is odd numbered. So for odds, my first pull would be odd. That's going to be, let's see, we have 3 odds there, and then we have 4 odds there. So that means it's 7 out of the total of 13. And then the second one is even. Well, I have 6 evens left over, but only 12 total, so that's going to be 1/2. And then lastly, kind of the other way, oh no, it's even. So for even, let's see, I have 6 even out of 13 to start, and then if I get 1 on the first, that means I only have 5 out of 12 on the second, so that's my answer there. All right, last up here, this next one says, find the probability that both of these spinners stop on blue. So that means it's kind of an and question here. They don't say the word and, but I need them both to happen. So it's 1 out of 4 for the first one. And then the second one is going to be 1 out of 8. And so since I need both of those to happen, I'm going to multiply them together. So it's going to be 1 out of 32. They both stop on purple is going to be 1 out of 4 times 2 out of 8. So that's going to be 1 out of 16.